Okay, we're going to continue talking about how you interpret all this data you're getting from your long-term monitoring program. I know that when I have a bunch of monitoring data and I want to know what it means, I look at it as an opportunity to ask the man.
Well, I know you're talking about the man-Kendall analysis, which is your favorite method for determining concentration trends, if for no other reason than it lets you keep telling that joke time after time.
Okay, so exactly about asking the man. But first, why don't you tell us why trend analysis is such an important part of monitored natural attenuation?
Well, it's important because it allows us to answer some really important questions. The two primary ones are shown here, but we're basically, number one, are contaminant concentrations decreasing over time? So there's a log concentration shown here and time on the x-axis, and you're progressing towards some cleanup goal, which is related to then number two is when will these concentrations fall below that cleanup goal?
So it's sort of, are you going in the right direction, and then how long do you have to wait, until you get that cleanup?
Yeah,
right?
and we need to do this because of some of the issues with monitoring data itself, right?
Okay, and then there is this idea that we have those short-term variability, that can make this really challenging. You need statistical methods to sort of break through some of these clouds, and you also want to avoid recency bias.
Yeah, so I mean, I work on a lot of sites where the regulator will wait from event to event and say, well, that well went up and that well went down. And you got to sort of avoid, the recent picture. You got to take the big picture. And trend analysis is something that really helps us do that with statistical power.
Right. And so the whole business, the whole problem here really is with this business is that there is all this noise in these monitoring wells. And I know our colleague, formerly at GSI, Dr. Mindy Vanderford, she had this expression that she talked about these monitoring wells, what's her question was, what's the difference between a monitoring well and a man, right? And you remember her reply?
I don't, but I think you do.
She said at some point they're both going to lie to you, okay? But it was just her sort of humorous way to sort of suggest that we do have this instrument that does give this variability, and we need statistical methods like the man-Kendall to sort of break through and do this.
Okay, well, that's a good analogy. Let's go into the sort of nuts and bolts of the man-Kendall trend analysis. Just to back up a second, though, a lot of people do, in terms of establishing trends, rely a lot on linear regression. And that has a lot of utility, but one thing to remember is that's a parametric test, and so it has sort of built-in assumptions about how it works and how the underlying data are. It really has this assumption that the data are normally distributed, and that really isn't always applicable with environmental data. So a lot of times we want to switch to something that we call a non-parametric test, and that's what the man-Kendall test is. It's a test that by definition makes no assumptions about the underlying distribution of that data.
Has less statistical power, but it's more flexible and sort of more reliable in some ways.
Yeah, and so it gets used a lot in these cases. And other things to remember then about man-Kendall is it really only cares about the relative magnitudes of concentrations. It's really sort of this ordering system that it goes through, and so you're really just sort of ranking things. Like Chuck mentioned, it's a little bit easier to establish a trend. The thresholds are maybe a little bit lower. On the other hand, it handles non-detects a lot better than something like linear regression. And then the most important thing for a lot of people is it's pretty simple to use, and we're going to go through some examples here as we go through this lecture, right?
Okay, let's dive in, and basically you're going to look at some of these different variables and combine them and then put these different data sets, what we call temporal records, concentration versus time, into different buckets. But what are some of the key factors here? Yeah,
so this is a statistical method, so you're basically calculating a test statistic, and for the man-Kendall we call it the S statistic, and that's shown here on this first row. It's basically indicating if the trend is increasing, in which case that S statistic would be positive, or decreasing, it would be negative.
Now, if you actually look up the man-Kendall in a statistics book, this is really what they're talking about. It's just that statistic.
Yeah, that's the key metric in this case.
But for this particular method we're going to talk about today, there's sort of these added sort of elements to it to come up with this system. So tell us about the other two factors.
The second one that's listed there on that table is this confidence factor, CF. So that you can think about that as like 90% confident, 95% confidence, or related to that sort of p-value that you see for a lot of statistical tests. So it reflects the degree of confidence in that particular result. Then third there is the coefficient of variation, COV. So this is the variability in concentration versus time data. And in this case, for our purposes, we're using that to determine whether there's a difference between a stable or no trend at all.
Okay, and so a lot of statistics here. I guess just a quick question is that do I have to do all this on my phone or my slide rule? Or is there a tool that people can use?
Well, I hope they don't have to rely on a slide rule, because that might be hard to come across. But yes, the answer is there's a tools out there that are available to do this. One we're citing here, basically down there. What's that, Chuck?
That's this the Man-Kendall toolkit, actually from GSI Environmental. It's free. It's a spreadsheet. You can download it at the webpage there. So, Dave, these are the input data. What do you get from all this?
Well, the goal here, remember, is to establish a trend. And so you can use those combination of those metrics basically to sort of assign a trend. And we like to call these bins that you might fall in. And so here's your S statistic and your particular confidence in trend. But quickly, you want this to then determine which of these sort of bins that you fall in. And so, for example, let's take a look. If I had an S statistic that was greater than 0 with a CF, a confidence factor greater than 90%, that would actually put me then on that right-hand side into an increasing trend.
Slam dunk, your data's going up, that's it. But if you have a little more murky, let's say you've got a Man-Kendall S statistics that's less than 0. I'm like the second to bottom row there.
Sure.
And you sort of got this confidence between 90 and 95%, so still pretty confident, but maybe it's a little more variable than the other one. We'd put that in this bucket, probably decreasing, and that's the second to bottom row.
Okay, so at the end of the day, you're going to run the Man-Kendall test. It's going to tell you which one of these categories that you fall in.
In 6 different buckets, there's increasing, probably increasing, stable, probably decreasing, and the last one?
No trend, basically that you don't have enough data to establish any sort of trend with any statistical power.
Right.
Okay, so let's take a look at an example, a bird's eye view then here of maybe a plume with all these monitoring wells here. In a lot of cases for M&A, we're interested really what's going on in that sort of the toe end of the plume, right? And then let's take a look at data from one of those wells. So there's MW1 is listed right there, that light green towards the down gradient end. And then we've got some data shown here, and we've got concentration on the y-axis in micrograms per liter. So think of it as maybe TCE or something like that. And then we've got the sampling date on the x-axis. So each of those individual points is a concentration data point that you have for that particular well.
Okay, about 4 years of data. It looks like it goes down, but then it goes back up.
Well, I'm going to ask you, Chuck. We have a chance to see your knowledge on this. What do you think the trend will be for this particular well?
Yeah, looking at that, I'm tormented. I'm torn. You know, it goes down from what, 8 down to almost 2 micrograms per liter. Things are looking good, but there's this little kick at the end. I just don't know. So you know what I think we should do?
Tell me, please.
We got to ask the man. What does the Man-Kendall sort of method say? What bucket does it put this in, and how do we do this?
Well, we're going to download the toolkit, or you can do the GSI one, or there's other online calculators if you want to do this. But basically, in these sorts of cases, you've got this this spreadsheet set up to easily sort of enter your data. So that's what you're going to do. You're going to take that data that we showed, and you're going to put an individual data point on each row. It's associated with a particular sampling date and a concentration measurement on there.
So it's just a calendar date, and then here's the concentration. Now this is a non-parametric method, so it's sort of comparing the not the absolute values of the numbers, but sort of it ranks them and then does this sort of sorting based on that. But you just copy and paste these in there from your data set?
Yeah, it's pretty straightforward case in this, and we've got the chance then to see what the trend is. It's plotted the data again here, but you basically got an automatic calculation of your trend. So what do you think? Do you think you're right, Chuck?
I think it's decreasing. I think I'm just going to look at the overall weight of evidence and just eyeball it. What does Man-Kendall say?
It says it's decreasing, and so it'll actually output, in this case, your coefficient of variation, your Man-Kendall's test statistic, your confidence factor, as well as the overall trend in here. So we've got a decreasing trend based on this data set.
Okay, here's a question. Let's say I got 2 years of data, I put it in here, and it says it's probably decreasing. And then I get, over the next 2, 3, 4 years more data. Can that trend change?
Yeah, that trend can absolutely change, and so you're just amending these with the future data in these cases.
But based on the last lecture, once you get to maybe 7 years of data, very rough rule of thumb, maybe you'd start really seeing that thing stabilize and you'd be more firm on it.
Yeah, maybe less event-to-event sort of change in the overall trend.
That's right.
So there's one example. We put another example up here. Then this is sort of the red dots on that on the concentration versus time there. And so here's an example of maybe in a source area where you've got higher concentrations, but you've got a longer record. So you've got data from much earlier than you did for that MW1. So MW2 started in what, about 2006 where you have data, but then you had a long gap in here. Yeah. And so that can be really problematic when you're doing things with linear regression. It's not very good at handling those gaps. So in this case, Man-Kendall, not a big problem, right?
Not a problem. He just sort of ranks through. They're going to rank these data and tell us what that trend is.
Okay, so not sensitive. What do you think in this case? What are we going to get out of this, Chuck?
Probably decreasing?
I think we're going to have decreasing.
It's still
in this
decreasing.
one. Yeah,
Okay.
so in this case, we still are able to establish a trend with that data.
Okay, well, the man is a lot smarter than me, so I'll believe the toolkit.
Okay, well, that's good. All right, well, let's look at the key points then from this lecture. Statistical methods like Mann-Kendall provide a great way to establish long-term concentration trends in data that exhibit significant short-term variability.
Okay, in Mann-Kendall, it's a non-parametric test, and it makes it suitable for M&A data that can range over several orders of magnitude and may not be collected at regular frequencies.
And then this trend analysis, pretty easy to perform. There's a lot of free software tools available to do it.